Okay, I guess it's pretty much the time, and I guess we are good to start, right? I'm gonna start a quick introduction. Okay, thanks everyone for coming. I'm the moderator today, and it's my pleasure to have Dr. Ed Mosteig to be here talking about standards-based grading in a differential equation courses. Ed is an amazing teacher, scholar, colleague, and especially a great mentor to me. I have been trying to invite him to give a talk here several times. Finally, I succeed. Well, this is going to be only 25 minutes talk, so I'm just going to be shut up and leave the stage to Ed. Thank you.
Great. Thank you so much, Yangping. So I wasn't sure how to pitch this talk because I didn't want to make a lot of assumptions whether people knew about alternative grading systems or any of the particular types of alternative grading systems. So I'm going to treat it like nobody out there is familiar with these systems. So it'd be a little more general than I might have given at another conference. But again, this is great if like you're not sure what this is all about, or you know a little bit about it, but never really dipped your toe in the water and gave it a try. This is my attempt to tell you should give it a try. So I'll tell you, I absolutely love my job. I love teaching and doing research, working with students, trying to like inspire them, mentor them, challenge them with fun problems. But you know, there's one aspect I think we can all agree on that is not necessarily their favorite. It's the specter of grading looming over us at every corner, especially during finals time. So what I want to do is first tell you like where this all came from, how the grading got started essentially. So it's sort of a little mini history in the US. So Harvard University is one of the first institutions to make students actually do something in terms of demonstrating your knowledge to get a degree. They actually had these exit exams at the end of their time at Harvard to earn their degree at that very end. Yale upped the ante a little bit in 1785. They graduated people with the equivalent of like honors, highest honors, or you don't graduate, things like that. They had 4 different levels, and of course they had to put them in Latin, as you can see there. Horace Mann, who is who's known sort of as the American father of the or the father of the American public education system, was an abolitionist. He proposed the idea of having the students do written exams and report cards. The idea there is he believed that all students, regardless of their socioeconomic status, deserved, you know, a good, solid education. Now, the problem was it wasn't really, it wasn't uniform, still is not uniform, but grades themselves were not really considered. People didn't know actually how to determine at what level their kids were reading or writing or doing math at. So he came up with this idea of instituting report cards so that parents had some idea of where their kids were and where they had to go. It wasn't meant to compare them. It had nothing to do with a bell curve. It was just so that, you know, they could check in and see where, you know, progress is being made. And then in 1884, Mount Holyoke is the first college, as far as we know, to really come up with a grading system where each individual class had different letter grades. So each individual class, you would earn an A, a B, a C, a D, or an E. So I want to open up the chat window. Does anybody have a guess? Maybe you could shout it out or type in a guess, like why we don't have A, B, C, D, and E anymore. Oh, yeah. So
excellent.
Yeah. So Yangping read the book or the study guide. So yeah. So they didn't want anybody to be confused by the E, thinking that it was excellent. So that's how they changed it for F, and we know what that stands for. All right. So with the chat window open, we just have a small group here, and yes, F indeed means failing. What I want to do is ask, you know, the small group of you type in something in the chat window. What do we measure with grades? So it could be something big or small. We measure lots of things that we hope to measure. Some things we measure incidentally, and some things we measure in our grades that maybe we don't know if that's a great idea. So it could be very generic, like what do we measure with grades? So like one thing would be students, proficiency with the material. Or it might be more about metacognition. So I'll give it just like 30 seconds. Yeah, understanding is is the big idea. Oh, yeah, Daniel, ability to communicate. So there's another idea there. We certainly measure that. Some classes, maybe that is what we want to measure. We all need to be able to communicate in whatever language we're talking about. So lots of understanding and proficiency. And that's really what we want to get at. That's what we hope that grade at the end measures. So here are things that many of us measure, whether it's intentional or not. Mastery of course content, that's what you were all talking about, proficiency or understanding, ability to apply that knowledge or transfer to a different domain, engagement in the class, attendance, participation, in the chat window, satisfying course outcomes. Thank you, Samira. But then we also measure things like effort, submitting work in a timely manner, right? If students don't turn in their work during the deadline, then obviously that impacts their grade, written and oral communication skills. I see, the satisfying course outcomes. Most of us are familiar with, like, a lot of our schools, you have to write some sort of learning outcomes for every one of your classes. Sometimes that's frustrating and challenging, but it's also a really good idea in terms of designing a class, like backwards design. You have your outcomes. How are you going to design the class to make it so the students will reach those outcomes by the end? So what I want to do is talk a little bit about those ideas, like level of understanding is what we really want to measure. There's a book here that I recommend, not exactly with reservations, but if you read this, approach it from the mindset of just challenging some of your ideas. Some of these ideas you may really like, but some of them will just be thought-provoking and get you thinking about how we can change our mindset or framework for grading. This book is written by primary and secondary school educator, principal, administrator, and talks about the different ways that unintended consequences, things enter in the grade book that we might not necessarily want to have entered. So, we certainly want the grades to accurately reflect understanding of the material. We want them to be bias resistant. So meaning that, just because you have a student who's working really hard and asks really good questions, it doesn't mean they've necessarily learned the material really well. And we're doing that student a disservice by just saying, you go on and move to the next course unless you have a real solid understanding. And perhaps one of the most challenging things to tackle is intrinsic motivation. Grades inherently are an extrinsic motivation that can winnow away at students' curiosity and willing to explore and make mistakes. We really want to foster this intrinsic motivation on the part of the students. I'll say there's two things I want to address about the way traditional grading systems tend to go. One is the observation that a student could pass a class, so say they could pass a class in differential equations without having done a single problem correctly, right? If they're getting partial credit, they could end up actually getting a C in a class, but not really being able to put it together for any problem. And that's sort of an odd thing to ponder. But perhaps more importantly, at least to me, it's kind of a personal issue, is I'm sure we've all had those students who are working their tails off. They don't come in with like the prerequisites, like really strong. They don't have a real strong, solid foundation, but they're working their tails off. And by the end, they put it all together. They've done so much. And you would put them up against anyone else in the class to, say, hey, could you present this material to the class? You feel like they could do it, but, the first exam, they failed. The second exam, they were still struggling, but doing a little bit better. And then by the end, they finally figured it out, but they have these really low scores at the beginning. They can't dig themselves out of the hole. But in the end, they have as much of an understanding as any other student. That's something I'd really like to avoid. And that's really one of the main motivations of these alternative grading systems. There are many different types of alternative grading systems. There's not a fine line in the sand between one and the other. If you're approaching this idea of using alternative forms of grading, I would say just think of all these different forms as a buffet. You're picking and choosing pieces that best suit your teaching style and your students. Here are 3 books that are forms that I'm not going to discuss today. I'm going to discuss a 4th one. The book Ungrading doesn't mean you don't assign grades necessarily. It doesn't mean no grades. In the end, we all have to give grades for the most part, but it has to do with putting all of the emphasis on that feedback you're giving the students and not just giving constant number letter grades. In the end, there's just some sort of grade, but you're showing them where they should be, striving for. Specifications grading is a little bit similar to what we're going to talk about today. There are some slight differences there. The last one, labor-based grades or contract grading, is not used in STEM so much. It's used a lot more in the humanities, although I've seen it gain some traction in STEM. It's an interesting idea that has overlaps with others, but the idea is the student will, in concert with the instructor, will essentially say, draw this contract. They'll say, I'm going to go for a B in this class, and this is what I have to demonstrate to get that B by the end. So what's interesting is like students will draw different levels of contracts. It's not every student will say, I'm striving for an A. What we're going to talk about is, you can see these 4 forms I put on the slide here is the last one, standards-based grading. This is a book that came out in July that is really a good entrance into all this because it touches upon so many different types of grading. And so it's, between, one set of covers, you can really learn a lot about what different people have done. Standards-based grading is in some ways the lowest hanging fruit because you can just change one piece of your scheme for assessment. So what I've done for 3 semesters now is something called standards-based testing. So it's within that umbrella of standards-based grading, but it's just for the exams themselves. Other parts I've changed a little bit or left unmodified. So I'm sure we've all seen this happen before or know about this. After the exams, all the students, they look at their scores and then they shove them in this corner of their book bag, all crumpled up, and may never look back at that. And that's a big opportunity lost there, right? The idea is like, we hope that they can go back and learn from those mistakes, but that's not really how a traditional grading system is set up for the most part. The one exception is, of course, the high stakes final exam at the end, where they're trying to put all that together. But there's not a lot of emphasis on growth throughout the semester. So that's one thing that I strive to change, in the standards-based testing setup that I have now. In that book, Grading for Growth, they put down 4 pillars, and everybody steals this idea, it seems, with different alternative grading systems, because it really captures the idea of what you want to do when you're moving away from traditional based grading. You want to have clearly defined standards. Think learning outcomes. What are the things you really hope the students can do by the end of the semester? Feedback, that feedback loop is so important because hopefully the students will use that feedback in some capacity to learn and grow. You want to mark in ways that say the students are progressing, and you want them to be able to have multiple opportunities to demonstrate their competence with a particular standard without penalizing them for failing the first time around. I'm putting this slide out there. I know a lot of you probably are already familiar with this idea of mindset. Carol Dweck now seems to be like a household name in elementary and middle school, like that. So that's a new thing. Her research, she's from Stanford University. Her research stems back to the 80s. She really got started in 1978, talking about 2 mindsets, fixed and growth. And so in a nutshell, in just a minute here, fixed mindset is that like intelligence, talent, skills are all fixed. You only have what you're born with in terms of your ability to like do math. You have a mathematical mind. So if you study a lot, you'll be able to do well there. as opposed to in all these different domains, there's plenty of opportunity to grow. The idea here is we really want to make sure that we believe in this growth mindset, and therefore our students who hopefully trust us can start feeling that as well. If the instructors don't believe that students can grow, then they're not going to believe that in themselves so much either. I'll put a couple of links for a few things, at the very end of the presentation. Actually, I'll throw this right in here. So here's a link to that book that I recommended. And then if you don't know about growth or fixed mindset, or even if you have, this is a 3-minute video. It sort of shows where it all got started, which is a nice watch. But the idea is we want to make sure that our classes are imbued with these growth mindsets, and it comes back down to that feedback loop as well. So here I put together a few standards for a differential equations class. Not all of you may have, I assume most of you probably taught differential equations if you're here. Just for fun, put down some standard. Could be something related to these or something different, some standard, something you would like your students to have at the end of your, say, introductory course in differential equations. So we'll just take a minute out for that. It could be big or small. Oh yeah, modeling and right, that's so Daniel suggests modeling. It's kind of like big part of why we're here today, of course. And I'll say a little bit about that related to this testing setup that I'm talking about. Oh, Yangping, using Euler's method. Yeah, exactly, with initial conditions. There are tons and tons of things we could say here. This right here is a set of standards. I have my own, but I purposely stole this from someone. I'll tell you where I got this from. There's a repository of syllabi for different classes, including differential equations, where people have used different alternative methods. So this is one of them that I just grabbed because I wanted to show you what's out there in terms of resources. Oh yeah, testing physical reality of the solutions. I love it. So here, Drew Lewis, University of South Alabama, put together 24 standards. So what I want to do is say, take a look at what my grade book might look like. Here I have a really talented group of students. You can see Ada Lovelace is there, Euler and Ramanujan. It was a really good semester. I have all 24 standards listed at the top. And the way I structure my classes is I would have, say, the first exam might have 4 or 6 of the standards. So for example, exam 1 might have these 4 standards right here. And each standard might be 1 or 2 problems or so, whatever the topic requires. Some you might want a few extra problems in there, right? If you're doing model, you want to see if they can do modeling in different scenarios. So you'll have these 4 standards in the first exam. Here is what's a really big change. So I think this is where it all comes down to between what I used to do and what I've been doing now with standards-based grading, is each problem, I either mark it with a P for pass or an N, not yet, and I'll give a lot of feedback. I know people who have started with this and said, I can't just give a P or an N. It's maybe they did most of it correct. I want to give them sort of 4 out of 5 points. I've seen lots of people go back and forth. They've done that and they said, oh, wait, I'm basically back in traditional grading. They've dialed it back. So it's really personal to you how you might implement something like this. I've stuck pretty true with this. There are a few exceptions. I tell students if they pretty much nailed it, and I think they could get up in front of the class and present a problem on the spot, but there are a couple of arithmetic mistakes. I'll be like, okay, just come and demonstrate to me that you know how to do it. I've done this in 3 different ways. For really large classes, I've actually had them do a write-up and hand something in that way. If I'll have over 100 students, I can't go through a whole lot of rewrites and things. I can go through their individual rewrites. I think many of us have done something of this, you'll take the average of your original score and the rewrite. So it feels a little more like that. In my other semesters that are more manageable, I have smaller class sizes. I'll have them demonstrate to me that they can do the standard on the spot. So I've actually had students come to my office, show me what they did wrong, and I'll give them something on the spot. I was really fearful of doing this because I thought they would be afraid to talk to me about this. And it turned out to be much more rewarding than I ever anticipated. So that would be the gold standard. If I could do that every semester, have them come to my office and have a conversation on the whiteboard, I would do that. If you feel like you can put the students at ease, it turns out to be a much richer conversation and helps them develop more confidence about their abilities to do this material. I know colleagues who have actually done something like this, but the students will come during office hours and they'll hand them another problem that they have, they can go to a neighboring room and write up and hand that in. That's a really good idea too. It can be really labor intensive and a lot of pushback unless you have lots and lots of office hours that the students can attend. So the way I've tried to find a medium between the two is I do all my testing in class, including sort of like their ability to redemonstrate knowledge of a standard. That's particularly useful during those semesters when I have over 100 students. So you can see here are the marks that everybody got, a P or an N on exam 1 for those 4 standards. Here at the bottom, I'm just making a note for us to see what has Ada Lovelace done so far. So exam 1, you can see she passed C1, C2, and C4. So that's right down here, but not C3. So what I'll do is the next exam, exam 2, everybody will have something a little bit different. Ada Lovelace will get those 4 new standards, and then there'll be another problem related to that standard she didn't get, C3. So there's a lot of overhead. This is a lot of work the first time you do it. So I'll say what everybody says is like, start small. Like if you've not done something like this, just change a little bit. You don't have to have the perfect grading system. Just change something just a little bit and see how that goes. So here you can see in exam 2, Ada Lovelace no longer has an N for C3 because she got that on her second attempt. But this time around, she passed C5, C6, F1, but not F2. And on the third exam, that means she'll have to just take F2. And then perhaps she got F2. She didn't quite get it this time either. But F2 and S1 are the only ones remaining. And then on the next exam, then we'll go through and maybe those will be 2 old standards that she has to redo, including the new ones. Some students point out that this feels overwhelming because like they'll have more problems than others to do, right? For example, Ada Lovelace only has 2 problems, but Ramanujan will have 5 old standards that he'll have to do. And so it's something, worth considering. Here's a real simplified grading rubric. You can just say how many standards did they pass by the end of the semester. One thing I really like is oftentimes my finals are just whatever standards they haven't passed so far. It takes a little bit of timing. My grading rubric really isn't quite this simple. I have projects and things like that. I think projects are a really nice way to, I should say, one really nice thing about standards-based grading, if they're working on projects, you can go back and see which standards they're struggling with, and they can too, and you can have a conversation about that so that what things do they still need to do before they can, delve into these projects.
We have 2 minutes left. Sorry for the interrupting.
That's perfect. So thank you. I'll say, how has this changed my class? One huge thing that's changed is the conversations. I no longer have conversations about with the students after the exam. Should this be like 3 out of 7 or 2 out of 7? I find that's maybe the most painful part of doing this, of grading. But even the grading itself, when you're trying to make those decisions, is really hard. Here, you're just writing it all out in feedback. You're just saying, oh, look, you're missing this piece right here. Not yet. I think there's some value to you coming back to the standard and reattempting it. So that's changed a lot. And then the other thing that's changed is the conversations I have in my office. I'm just having conversations about material nonstop, and students I'll connect together. Maybe one got one standard and the other got the other. I'll have them help one another. So I see a lot of like sort of cross-pollination and collaboration taking place a lot more there. And the last thing that I'll leave up is just, if you want to know more, sales pitch for a conference that I'm not part of, but I've gone to for a number of years now. And there are lots of resources. If you hit that resource tab, you'll see lots of things like syllabi and such there as well. So anyway, if anybody ever wants to chat with me, drop me a line, and I'm always happy to talk about this stuff. Thank you.
Thank you. This is great. Do we have questions from the audience?
I was wondering, sorry, I should put my hand up or something.
Hey, Daniel.
Hi, nice to meet you. This is fantastic. I'm doing something similar actually with my real analysis and complex, but
Nice.
haven't rolled it out for my kind of 200 level courses, which is what Diffie is for us. For the
Yeah.
exams, how many, I can envision doing this where the standards are, where the exam would be shorter than my traditional exam. So it has like a question for each standard that may be a little more involved and give them more time to kind of work through it. What do these exams look like? Are they, do you feel that they're shorter or are there multiple questions for each standard? Maybe that's what I'm getting at.
Right. So actually, you bring up a really good point. So definitely, most of these standards have a few questions or so, and everybody's trying to find that sweet spot. One thing that I really struggle with is coming up with interesting problems that I think that are really probing. Sometimes they feel like quiz questions, but maybe a little bit harder than that. And that's where I feel like it's really good to have those projects. Otherwise, they're not able to take that material and really synthesize it in some way. But yeah, I typically try to make it on a page or so. But yeah, if you're trying to model like interacting populations, one question is not enough, of course.
Right.
Yeah.
Thanks.
Mario.
Hi, I'm Mario at Fresno State, California. So I had a question. It might feel maybe like a two-parter questions. And so part of it is, could you speak a little bit more about the overhead for implementing these kinds of ideas? And on that note, you sort of mentioned that because it's large overhead, then maybe it's good to sort of work with smaller transitions at a time. And so that being said, how did you sort of get to where you are now, and how does that relate to, again, the amount of overhead involved?
Right. So I'll say I just jumped right into it. So I guess it's a cautionary tale in that sense. What I know people will do is in a class, maybe there's some very mechanical computational things. Maybe there are like 5 or 6 skills that people need to do. They just need to be able to like, maybe they need to solve first order differential equations with constant coefficients to do lots of other things in your class. Maybe I'll have just like 5 or 6 standards and they'll be like quizzes. The big overhead is just writing lots of versions of the problems where you don't feel like sometimes you're just changing numbers, but that's sometimes just changing numbers doesn't really do much for them, right? They're like, they just memorize how to do that one problem. So I think the big overhead for me was writing lots of versions for those standards and then having the ability like in the class to distribute different standards to different people. Probably the easiest way to implement that, one of my colleagues will just put them out on the front table and then that old standards and the students know which ones to grab. For me, I write like a Python script that will actually print out these tailored exams for each person. That's not necessarily something that's reasonable for everybody to do. But yeah, I would say maybe a few standards is good enough at the beginning.
Any other questions? Well, if not, let's thank our speaker again. Thank you. Oh, there's one more actually in the chat.
Oh yeah. Oh yeah, homework. So that's an interesting thing. So I have them do written homework and I do web work. Web work, I stole an idea from a colleague where if they do the web work on time, they get 80% of the score, or they get 100% of the score. But if they turn in all the way up to the last day of class, they get 80% credit. So that gets them to get it done. And they, there's that feedback loop. They know if they're doing it right. Obviously, lots of us have issues with web work, but I do like them knowing whether they're getting the right answer or not. But also web work, you're not forcing them to practice to writing out solutions. So for that homework, it doesn't count quite so heavily, but I have tiers. So the way it works is you have to get this percentage of the homework correct, or just attempt this percentage of the homework in order to get at least the passing grade, and I'll have different tiers in there. So Some students could pass all 23 standards. If you don't hand in any homework, that actually will lower your grade. So yeah, people do it different ways, but usually I say, in order to get a C in this class, you have to have done this much homework and get this many standards, for example. But lots of ways you can mix that around. All right, thank you everyone for attending. I'll hang out here for a few minutes, but feel free to reach out to me another time if you want to talk then too.